This is problem number 2 in Giancoli chapter 5. The problem reads, a jet plane traveling at 1,890 kilometers per hour pulls out of a dive by moving in an arc of radius 6 kilometers. What is the plane's acceleration in g's? A couple of notable things here. The velocity of the jet, 1,890 kilometers per hour, is already converted for you into meters per second. So let's go ahead and write down what we know. We know this is actually going to be our tangential velocity, 525 meters per second. We know that it's the velocity tangent to the circle. So at any point along that circle, here it's 525. Earlier up in the arc, it's still 525, but its direction has changed. So wherever it is in the circle, it's at 525. I'm sketching it here at the bottom, but we could have sketched it anywhere in that arc. Of course, this is an arc. They give you the radius to the center of the circle being 6 kilometers, or I could convert that to meters and say that the radius is equal to 6,000 meters. Okay, so I'm going to start this problem by simply saying that the centripetal acceleration, which is ultimately what I'm being asked about, is v squared over r. What's up, buddy?
I'm done with the show.
Okay, hold on one second. I'm going to finish this physics problem for my students, all right? All right. So centripetal acceleration is v squared over r, and so now I'm going to plug in this number, 525 meters per second. I have to square that, and I'm going to divide it by my radius, which is 6,000 meters. And when I run that through my calculator, I'm going to get something on the order of about 45.94. Of course, our units of acceleration are meters per second squared. And lastly, I need to basically convert that to g's, where I can say that basically 1 g is 9.8 meters per second squared. So I'm basically multiplying my answer times this conversion factor of 1 g is 9.8 meters per second squared. When I do that, my centripetal acceleration, or I can call that my radial acceleration, is 4.69 g's. And that's the solution to problem number 2.